Hello children, welcome to the science video session. Today we are going to enter into the new lesson, electricity from physics of standard 6. Come, let's move on to the video session.
Unit 2, Electricity. Introduction. We use electricity in our day-to-day life. Have we ever wondered from where do we get this electricity? How does this electricity work? Can we imagine a day without electricity? If you ask your grandfather, you can come to know a period without electricity. They used oil lamps for light, cooked on fires of wood or coal. By the advent of electricity, our day-to-day works are made easy and the world is on our hands. So, what are the appliances those work on electricity? What are the materials those allow electricity to flow through? What are electric circuits? What are electric cells and batteries? Come on, let us listen into this lesson to know more about electricity. Sources of electricity. Children, how do the electric bulb lighten up when we switch on the switch? It is due to electricity. Where do we get this electricity? We get electricity from thermal power, hydel power, tidal power, wind power, solar power, etc. as sources of electricity. All these plants exist everywhere? No. These plants are constructed depending upon the natural resources available at that particular place. For example, we have thermal power plant in Neyveli, Tamil Nadu, as lignite is available there. And we have windmills near the hills of Tirunelveli district which has potential wind resource. Do you think we get electricity only from the above mentioned sources? No. Look at that wall clock in your home. How does it work? It needs electrical energy to work. Apart from the above mentioned sources, we get electricity from cells and batteries. So, what are sources of electricity? Any device from which electricity is produced is called the source of electricity. So we get electricity from different resources. Come, let's learn about that. The major electric power stations in Tamil Nadu are thermal stations, Neyveli in Kudalur district, Ennur in Tiruvallur district. Next, hydel power stations, Mettur in Salem district, Papanasam in Tirunelveli district. Then the atomic power stations, Kalpakam in Kanjipuram district, Kudangulam in Tirunelveli district. And windmills, Aralvaimuri in Kanyakumari district, Kayatharu in Tirunelveli district. Apart from this, solar panels which are prevalent in many places are used to produce electricity. Let us discuss shortly about working of power stations. First we are going to see thermal power stations. In thermal power stations, the thermal energy generated by burning coal, diesel or gas is used to produce steam. The steam thus produced is used to rotate the turbine. While the turbine rotates, the coil of wire kept between the electromagnets rotates. Due to electromagnetic induction, electricity is produced. Here, heat energy is converted into electrical energy. Next, hydel power stations. In hydel power stations, the turbine is made to rotate by the flow of water from dams to produce electricity. Here, kinetic energy is converted into electrical energy. Hydel stations have long economical lives and low operating costs. Atomic power stations. In atomic power stations, nuclear energy is used to boil water. The steam thus produced is used to rotate the turbine. As a result, electricity is produced. Atomic power stations are also called as nuclear power stations. Here, nuclear energy is converted into mechanical energy and then electrical energy. Next, windmills. In windmills, wind energy is used to rotate the turbine to produce electricity. Here, kinetic energy is converted into electrical energy. Now we are going to know about the another source of electricity, cell. A device that converts chemical energy into electrical energy is called a cell. Chemical solution which produces positive and negative ions is used as electrolyte. Two different metal plates are inserted into electrolyte as electrodes to form a cell. Due to chemical reactions, one electrode gets positive charge and the other gets negative charge, producing a continuous flow of electric current. Depending on the continuity of flow of electric current, cells are classified into two types. They are primary cells and secondary cells. Primary cells. These cells cannot be recharged, so they can be used only once. Hence, the primary cells are usually produced in small sizes. Example, cells used in clocks, watches, and toys, etc. See, some of the primary cells are given in the picture. They are dry cell, AA battery, AAA battery, 4A battery, 9-volt battery, and the button cells. Secondary cells. A cell that can be recharged many times is called secondary cell. These cells can be recharged by passing electric current, so they can be used again and again. The size of the secondary cells can be small or even large depending upon the usage. While the secondary cells used in mobiles are in the size of a hand, the cells used in automobiles like cars and buses are large and very heavy. Example, secondary cells are used in mobile phones, laptops, emergency lamp, and the vehicle batteries. Next, battery. Often we call cells as batteries. However, only when two or more cells are combined together, they make a battery. A cell is a single unit that converts chemical energy into electrical energy, and a battery is a collection of cells. Warning: all experiments with electricity should only be performed with batteries used in torch or radio. Do not, under any circumstance, make the mistake of performing these experiments with the electricity supply in your home, farm, or school. Playing with the household electric supply will be extremely dangerous. Electric circuit. An electric circuit is the continuous or unbroken closed path along which electric current flows from the positive terminal to the negative terminal of the battery. A circuit generally has a cell or battery, a source of electric current, connecting wires for carrying the current, a bulb, a device that consumes the electricity, a key, or a switch. This may be connected anywhere along the circuit to stop or allow the flow of current. Inside view of torch. A torch is a practical example of a simple electric circuit. It is an electric device that emits light. It consists of a bulb, electric cells, and a switch. See here, the bulb is turned off because the sliding switch is in off position. So, the circuit is not completed. Next, we are going to know about what is open circuit. In a circuit, if the key is in open, that is off condition, then electricity will not flow and the circuit is called an open circuit. The bulb will not glow in this circuit. Here you can notice the key is in off position. Next, closed circuit. In a circuit, if the key is in closed, that means in on condition, then electricity will flow and the circuit is called a closed circuit. The bulb will glow in the circuit. So, when the switch is on, that type of circuit is called closed circuit. Next, we are going to see the types of circuit. They are simple circuit, series circuit, and parallel circuits. Let's learn the circuits one by one. First, we are going to see the simple circuit. A circuit consisting of a cell, key, bulb, and connecting wires is called a simple circuit. A simple circuit is shown in the picture. Next, we are going to see the series circuit. If two or more bulbs are connected in series in a circuit, then that type of circuit is called series circuit. If any one of the bulbs is damaged or disconnected, the entire circuit will not work. In the given picture, you can see the cell, the key, the connecting wires, and the two bulbs which is in series manner. Next, parallel circuit. If two or more bulbs are connected in parallel in a circuit, then that type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So, parallel circuits are used in homes. See, in the given picture, you can see the parallel circuit, the two light bulbs which is in parallel to each other. Symbols of electric component. In the circuit we discussed, we use the figure of electric component. Using electric component is complicated circuit is difficult. So, symbols of components are used instead of figures. If the symbols used in electric circuits, even complicated circuit can be easily understood. See the electric component, the figure of the electric component, and the symbol and their remarks are shown in the table. First, we are going to see the electric component, electric cell. The figure and symbol is also shown in the picture. The remark of the symbol is longer terminal refers positive and shorter terminal refers negative. Next, battery. The figure and symbol is shown in the picture. The remark of the symbol is two or more cells connected in series. Next, switch open. The figure and symbol is shown in the picture. The remark of the symbol is switch is in off position. Next, switch closed. The figure and symbol is shown in the picture. The remark of the symbol is switch is in on position. Next, electric bulb. The symbol and the figure is shown in the picture. The bulb does glow is in the first. Next, the bulb glows is in the second. Next, connecting wires. The figure and symbol is shown in the picture. The remark of the symbol is used to connect devices. Let's see the overview of this lesson. The flow of electric charge in a circuit is called electric current or electricity. Next, what is simple circuit? A circuit consisting of a cell, key, bulb, and connecting wires is called a simple circuit. Next, series circuit. A circuit consisting of a battery, key, bulbs, and connecting wires or connected in series is called a series circuit. Next, parallel circuit. A circuit consisting of a battery, key, bulbs, and connecting wires connected in a parallel is called a parallel circuit. Next, what is primary cell? Primary cells can be used only once. Next, secondary cell. Secondary cells can be recharged by passing current and used again and again. And what is connecting wires? Connecting wires are made up of conductors and covered with insulators. Do you know electric eel is a kind of fish which is able to produce electric current? This fish can produce an electric shock to safeguard itself from enemies and also to catch its food. Then, more to know. A meter is an instrument used in electric circuits to find out the quantity of current flowing through the circuit. This is to be connected in series in the circuit. Conductors and insulators. Conductors. The rate of flow of electric charges in a circuit is called electric current. The materials which allow electric charges to pass through them are called conductors. Example: copper, iron, aluminium, impure water, earth, etc. Then, insulators. They are called non conductors. The materials which do not allow electric charges to pass through them are called insulators or non conductors. The examples are the plastic, glass, wood, rubber, china clay, ebonite, etc. Safety measures to safeguard a person from electric shock. What you will do if a person get electric shock? Follow these. Switch off the power supply. Remove the connection from the switch. Push him away using non-conducting materials. Give him first aid and take him to the nearest health center. Do you know Thomas Alva Edison was an American inventor. He invented more than 1,000 useful inventions, and most of them are electrical appliances used in homes. He is remembered for the invention of electric bulb.